Hi, hello, ciao, see ya, hola, and welcome to this presentation about water. It's a beautiful gray and cloudy day. We're actually in the mist as we speak now, and I'm a bit chilly, as you see, but this is the perfect time to be actually talking about water. Luckily, I am inside. I have the stove going, and I know that this water is going to feed our landscape. Now, hopefully, this is going to be enough, but unfortunately, I know it won't be. So this is why I want to share with you today this presentation about the water cycle and how come it is off balance at the moment. And actually since quite a long time. This has been on people's minds for decades now. Scientists have warned about today's context, yet we have not yet stopped the consequences. Why is this? We feel it has to do with lack of information, lack of understanding. So this is our little grain of sand or little drop of water to help you understand why we should be doing everything we can to restore the water cycle and our watersheds. So if we are talking about water, what is it exactly that we are looking at? So water is life. Water is in every living being. There is no two ways about it. It is in me, it is in you, it is in the planet, and it is in every living organism. This is something that indigenous communities have very, very clear. And when we go back to the North Dakota pipeline incident at Standing Rock, you will have maybe already seen this, but 300 plus tribes from all over the planet came to Standing Rock to stand with their brothers and sisters against the American government who wanted to put a pipeline in under their sacred lake and burial grounds in the Indian Reserve. Now, history tells us that this has already happened and that it's gone badly wrong and that the pipeline has leaked, etc. But just to show that indigenous communities still have this connection with our natural ecosystem that we are actually part of, and that they will travel far and wide to show the rest of the world, hey, water is life. Water is sacred. Water is a limited resource, and we are ever more people. We need to learn how to share. And if we are good at that, then fantastic. But we need to actually also keep it on the land, keep it in the water cycle as it is meant to be, because right now what we are doing is evacuating it out to sea. What am I doing? I'm kind of getting ahead of myself. So water is in all of the fractals that exist on our planet. They are in larger systems, in atmospheres. There is actually a word for it, the hydrosphere. And they're also in the smallest of systems, like going into a plant or going into our own circulation system. Water is above us, below us, inside us, and in all of the fractals. It's also in all of the permaculture zones. If you are familiar with the term permaculture zones, you know that the house is zone 0, where we spend most time. The vegetable gardens and animals that may need daily care, they will be in our zone 1. When we go to zone 2, we need less time spent on maintenance and implementation of care, etc. So as we go away from the home, we need less energy spent, or we spend less time there. And nonetheless, water is present in all of these zones. So where is the water that we can actually use for our well-being, that the ecosystem needs for its living conditions? Because there is loads and loads and loads of water on the planet, but not all of it covers these living ecosystems needs. So if we look at the whole planet, we see that 97.5 or 97% of all the water on the planet is actually salt water, and it's in the oceans and in the seas. And a very, very small amount, 2.5 to 3%, some resources give you different numbers, is the sweet water or fresh water that we and a load of other living organisms depend on. And now, taking only this small percentage of limited resource that is water, then we can see that this water is not just there for us to use, it's actually encapsulated in the ice caps, a lot of it. A lot of it is deep, deep, deep under our feet in the deep aquifers. And now it is definitely not natural for us to drill down deep, make a hole in the Earth's crust and try and reach this water. So both of these extremes, if you want to call them that, on the water scale, on the freshwater scale, are out of reach. So the little blue line in the middle here that you see between the ice caps and between the deep aquifers, that is the water that we have access to, and that is only a 1% of a 2.5 to 3%. So actually, of all the sweet water in the world, only no, sorry, of all of the water in the world, only a 0.02.5% is accessible for us. Now that is a very, very small amount, a very limited resource, and water cannot be created. It goes around and around and around in the water cycle, but it will never be lost or it will never be created. Unlike soil, for example, which is a renewable energy form. But where is all this water? Again, just to make it very, very clear visually, if you were to put the planet as a whole as a measure, you see that this is all the planetary waters together. And this smaller drop is all of the fresh water. And then this mini speck that you can't actually even see is that thin line that we can access. This is water in rivers, lakes, shallow aquifers, water that we can get to, or water that is in our ecosystem, in the plants, in the soil. And the use of this fresh water has, of course, gone up because over the years, and especially since the great acceleration after World War II, since the Industrial Revolution, and before that, actually, even already since we started to settle as a species and we started to engage in agricultural practices rather than going behind our food and being nomads or semi-nomads. So in the last, let's say, 150 years, we've seen more and more and more people settle or arrive on this planet. And since the 1950s, we've also got something that is called the Great Acceleration. So all of a sudden, we are quite comfortable, at least in some of the countries, and as they then sometimes call it, the first world or the developed countries. And this is, of course, on the back of the people in the global south and the so-called third world countries or developing countries. Now, water should be accessible for everyone, but as we see on the right-hand side, there is this chart that already indicates water stress in 2021. It's not going in the right direction if we carry on as now. Now, what is the natural water cycle, actually? Maybe you remember from back in your school times, if it is that you saw the water cycle, actually. And so water evaporates above the sea, and it travels across land, and it forms clouds. And once it gets to the head of the watershed, in the mountains typically, it rains down, and the water comes back to the sea through a meandering river system. Some of it will infiltrate in the soil and refill the shallow aquifers. The deep aquifers, they are not even discovered, and they are full and plentiful. So this is the natural water cycle. Now, what happened? Humanity actually settled and started plowing the fields, We also started building refuges and more permanent structures, and then actually we liked being by the coast. The very first settlers, of course, they were afraid of these natural elements and they stayed well away of the coast. But these days it's the place to be, right on the front line. So we want to be near rivers where there is a lot of, well, you can actually have transport, you could create energy, you could also enjoy the sediments that offer you great fertility. So we have then created our cities and urbanizations. We've paved over the soil, the ground, the lands, and all of a sudden water is no longer infiltrating as much. And for sure, we don't have as much of this evaporation over land because the cultivated fields, they actually no longer have vegetation that evapotranspirates water into the atmosphere, and then actually with the nuclei that are in this water vapor, the water attracting nuclei, which are actually bacteria that travel up with the water vapor, they no longer exist. So they can't call the water vapor in the clouds down to form a drop. Now, how this all happens is, of course, a bit maybe scientific. But what we need to understand is that we need trees to actually form this small water cycle. The small water cycle is often forgotten, or at least it has been until now. And another topic that I just want to touch on briefly here is the wells that we have drilled. When the superficial water, the water in the rivers and the lakes and the shallow aquifers have no longer given us what we need as humankind in our urbanizations, we have had the privilege of using fossil fuels, and we've been able to drill deep wells so that we can enjoy water whenever we want to use the water and open the tap. Now, what we don't see is the consequences down deep below our feet, because of course, imagine you have a cave full of water and all of a sudden you are emptying that water out of it. Now, water has a force and is keeping those walls open. What about all the cities that are above these aquifers and they weigh quite a bit? And you're emptying the force that holds their structure together. Boom! It does happen. I'll show you an image in a moment. So, and if you get deep wells on the coastline, another characteristic of water actually is that it will move towards an area of lower pressure. So if you are emptying something on the continent, but very close to the sea, which is this massive water body that is also in and of its own pressuring its sides, and specifically on the coast where all of a sudden it comes from very deep, sometimes up to very shallow, and then waves hit on the coastline. So the water in the sea will actually find its way through the rocks and through geological layers into those aquifers because it travels towards areas with lower pressure. So what you are in effect doing is the little amount of fresh water that we have, and yes, admittedly, this is the larger part of the fresh water because you've drilled down into that deep aquifer, but it still is a minimal percentage of the total amount of water on the planet. And now you are contaminating that with the salt water that is actually not that useful to us. It is much harder to cultivate and to wash with salt water than it is with fresh water. So our human presence has definitely had an effect. Whereas before you would have 95% of the water infiltrate into the soil, into the plants, into the shallow aquifers, and yes, over time also into the deep aquifers, but now we're talking hundreds of years maybe, depending on geology, of course. Nowadays, we have reached the scenario on the right, where 95% is actually runoff compared to the 5% on our original territories, and 95% actually now runs off quickly to the sea. Right. there was salt water in the sea, remember? So the fresh water is indeed mixed in with the salt water cycle. But before that fresh water drop comes back to us in the form of fresh water, 100 years, hundreds of years will have passed. I actually can't now remember the exact time. There is some information on that on the internet. How long does a molecule of water stay in each of its contexts? In the soil, in the river, in the cloud, in the sea. Very, very interesting, because you'll realize that it is lost into the sea for a long time. We won't see it back again soon. So what do we want to be doing? We want to be keeping it on land, right? Because especially now that we understand, since the October report of the Global Commission for the Economy of Water, now it has been given a spotlight. Of course, it's been known for longer than now, but now we can see that the green water, the small water cycle, is finally being recognized as part of our freshwater supply. So if we look at the ocean evaporation, part of it goes over the land and rains out, and part of it rains back out over the sea, yes, in these atmospheric rivers above us, but a huge part is actually cycled in the small water cycle, now called the green water. What happens above buildings? That doesn't take place. The water only evapotranspirates, and the transpiring bit is actually quite important there, because yes, of course, there is evaporation and a heat rising above plowed fields or above a parking lot or a skyscraper, but this humidity in the air doesn't have these nuclei, these bacteria, where the water vapor in the cloud can actually connect with and make a drop and then fall back to the earth. So this only happens above live vegetation. And we need to get that back, because of course our current situation is that we have deforested too many great areas and concreted them over or plowed them. So these atmospheric rivers that actually take this green water and rain it out more than never, it is in the head of the watershed, where you will then find the rain falling back down to earth. Actually, Dr. Milan, he comments that an area of 100 square kilometers, if I have that right, 36 square miles, is enough to make it rain, that you actually see the evapotranspiration above this vegetated, forested area, and then it will travel and find the atmospheric river to connect with and fall back down to earth above the next forest, where it will connect with these nuclei. Of course, that means we need forests or vegetated areas to actually call down that rain. And this is why sometimes it is called, we need to plant the rain. Rather than the rain comes from the sky, the rain comes from the soil. And so the percentages between blue water and green water, blue water being water that is in the system, flowing visibly in rivers and in lakes and in the rain, and the green water, meaning this is the green cycle, the small water cycle, the water that moves through the vegetation, through the plants. So if you have 1,000 liters of rain falling, I wish, you will need to take into account that half of that will actually not be in your lake or in your deposit or in your river. It will be in the plants and in the vegetation, because it is busy working and calling the next rains. So that will always be cycled. So this is something that we need to have very clear. If we don't have vegetation, we are cutting out that half, or when we go deeper inland, or even in the Amazon, for example, it can go up to 80 or 90% of our rainfall. If we clear cut those areas, we lose 80 to 90% of our future rainfall. Ouch. So this is an image by Laurent Denis, a French scientist who actually says that the normal figure would be 70% in that small or green water cycle, and that the evaporation from the sea only brings about 30% to the rainfall above the continents. And now what happens in our watersheds is that water, of course, travels down to the sea. And the sea also needs this fresh water to keep its balance, to keep the marine ecosystem alive and well. And what we are doing currently in our urbanizations, out of fear for the water, fear for flooding, and also just because of bad land management and land use, not in favor of nature, but rather going against it, we just evacuate water out to the sea much faster than it should be going. This means that we have less evapotranspiration over the continent, less green water in the small cycle, less future rain. This is what we end up with. We have massive rains when they do come, because I've already heard you thinking, less rain, less rain. It doesn't rain less, it rains too much at times. And indeed, if you have urbanizations that create this heat effect above the houses, above the skyscrapers, above the parking lots, they make it very hard for a cloud, for a storm cloud, to come into the land. So the only way they can get over that column of hot air is for them to create a big nucleus, for them to collect a load of energy, and then they are strong enough to finally get inland. And of course, that's when we get the downpours and the torrential rains. And if we are out of luck, then there is also a lot of lightning in there. The storm is electrical. And of course, with the remaining little pockets of vegetation that we have on land, they are very fragile. And when a lightning hits, maybe you will actually get total disruption, big fires. And of course, the water that comes out of these big storm clouds cannot infiltrate into any soil because there is no soil left. So it rapidly flows down, carries with it debris and plastics and contamination, and then floods the people near the coast. Sounds familiar, right? Unfortunately, we have seen it, and we see it more and more year after year. So what happens is we have the heat island effect on the coast, landscape dehydration in general because of bad land management and plowing and concreting everything over. We then get floods, and we have to deal with fires. Not exactly the top scenario for a thriving and natural ecosystem. And of course, as climate change gets into its larger and bigger and more potent feedback loops, every degree warmer means 7% more water is needed. 7% more water vapor is rising up into the air because the plants need to cool themselves by evaporating, by evapotranspirating into the atmosphere. And the plants are suffering warmer and warmer climates as well. So now what is here cause and consequence? Oh yes, it's because of climate change that we have a disruptive water cycle, or is it that we have a disrupted water cycle, which is at the cause of climate change, and the water cycle is disrupted because we have malmanaged our soils. So the changes in land use cause climate change, not climate change causes a disruptive water cycle. Of course, it doesn't help in restoring it, because these are now the challenges that we have to deal with. Whereas a couple of decades or a couple of 100 years ago, it was a lot easier to restore the damages done. Right now, we need to keep all these numbers into account, and we need to know that for every degree hotter our climates are getting, we are losing more water into water vapor. And the Mediterranean is also getting warmer and warmer because of more water vapor being up in the atmosphere and because of the temperature rising, of course. But it's an accumulative effect. And then what do you get when the water is all up in the air? You get a huge precipitable water column, as they call it. This is an image, a graph that shows us where it was in January. These are all the normal standard numbers. And here we see 2023 reaching a peak in September, which here in the Mediterranean is the typical gota fria, or the cold drop. And this is when the temperatures on the land all of a sudden at night are starting to drop, but the temperature of the seawater is very high. So a lot of water vapor is in the sky, and this means that there is a lot of potential rain. Now, when this temperatures on the field collapses and they attract all of a sudden these massive clouds of water vapor, then we get torrential rains. And of course, we have seen it also last year in 2024. Poland, Bologna in Italy, Valencia, maybe one of the more visible ones, the year before, Greece, Algeria, Italy, Poland, Romania, Austria as well in 2024. And on the photo of the right, you see that this is not just the water that we are having to deal with and that we want to get away quickly because we don't want to have flooded zones. We are losing our food sovereignty. This is fertility. This is topsoil. This is our food, the food of tomorrow, washed away into the sea, now slowly sinking down to a couple of kilometers down on the sea bottom. And this indeed here is the same. This is our topsoil. This is the food of tomorrow. This takes a long time to get back. Luckily, it is, as I mentioned before, a renewable resource. So soil can be regenerated, can be cultivated, can be made more, but for that we need water. So the next is water, vegetation, soil is all empowering. So when we look at the state of the aquifers, the deep aquifers here, we know what the state of our forests are, because forests are ecosystems with plants with very, very deep roots who actually drink out of these aquifers. So we are taking away the sustenance of the ecosystems that save our water future. And then, of course, it doesn't help that we have ever more wildfires because, of course, these trees that no longer have their feet in the water in aquifers that are now drying up, they are more prone to drying out, dying off, and then, of course, they call the fire because this is a natural cycle of disruption and regeneration. Are we close to the end? No! Rob Hopkins says we can fix this. Yes, we have to acknowledge it's warming. Yes, it is us. It is humanity. And yes, we are short. Yes, it's bad. I know you may be feeling anxious and disempowered, but let me give you the good news. And I stand with Rob Hopkins on this one. We can fix this. And so many other people, like the people at Water Stories, also believe that we can fix this. Because once you start working with nature, nature offers it abundance. And so this is the water cycle, the watershed that we want to be working towards. We want to go back to the original cycle of blue water and green water working together. And of course, we already have a lot of people living in the landscape. So what do we do with all these urbanizations? We need to re-green them, renaturalize them, reincorporate our homes within the ecosystem that we are living. Let water back into the soil, regreen because of cooling effects. In the cities, it's getting so hot. We need trees everywhere, not just to cool the rain, but also to cool our atmosphere, which then in consequence also lowers the evaporation rates, which then of course brings us back to balance and lets the water infiltrate in the soil again. For that, we need a healthy soil and we need plants. So they can't operate. Water needs soil and plants need soil and water, and the soil needs plants to create soil and water to feed the microbiology. So we're back to water in all permaculture zones and a fractal system. So we need to understand what we are working with in the way of water and its characteristics. What are we wanting to do with water so that it can stay on the land for longer and not quickly run off into the sea? How can we keep water close to us for as long as possible without, of course, flooding and getting sickness and damp in our homes, etc. We need to study the patterns. We need to become very, very clear on the pattern language. What is a watershed? Where does our water come from and where does it go? So bigger fractals here, for example, in the case of Europe, show that the blue side of the Europe map has water finally running off into the Atlantic and into the North Sea. The water in the red part of the map eventually ends up in the Mediterranean Sea, which is currently a lot warmer than it should be and has a huge struggle ahead with marine systems and microplastics and fish dying off, etc., etc. So this is the first fractal that we need to be aware of. Where, on which side are we situated, and what happens above us and what happens below us, and how much water is actually then the green water, how much water falls in total, how much water is blue water and goes back to sea eventually. We need to understand the pattern watershed. We need to know that we are actually in a bioregion and that we depend on what people are doing above us, and people below us depend on what we are doing. This is a true permaculture approach. We call this sectors. They are influences from outside of our home system that we need to take into account. We need to either work with them or deflect them or make them come through our system without causing destruction. So what is our context? What is the rainfall in our area? What is the slope? How fast does water come down? What activity is taking place higher up? What is the legislation? What can I actually even do? And should we not be collaborating with people in our watershed? So this is the basis for bioregional design. Maybe land frontiers and borders are not the best way to go. Maybe we should be looking at getting together with the people who live in our watershed. But then, of course, there's mini watersheds within larger watersheds, and the fractal systemic design comes in play again. And the element in itself is also of importance. We need to know what we are dealing with. Now, let me tell you, water is a mystery. We don't know what we are dealing with. Water is still under the microscope and is still being studied. And people like Dr. Gerald Pollack in this photo here on the right, they are being questioned. What are you saying? What do you mean there is a fourth phase of water? What do you mean water does crazy things like it makes this bridge when you have two beakers standing next to each other filled with water, and you put a charge in each of the beakers, but you move the beakers away from each other, the water will form a bridge. How does that happen? We don't even know this? Well, let's make sure that we do get familiar intimately familiar with all the water's properties that we do know about. Like, for example, it has surface tension, and like, for example, it's a universal dissolvent, or like, for example, it can be a thermoregulating body, or like, for example, it can quickly work with gravity, but it can also actually go against gravity inside the stem of a plant or a tree. Or there's so much that we can learn and that we do know about water. That is the basis for our work. And we'll just follow the scientific work closely, of course, to see what is being discovered on a daily basis. And this is something that is now coming up again. Water being energy and water even having memory, because of work of people who have already unfortunately passed away and not received any credit for their work, like Victor Schauberger, who spoke lots about the small water cycle and also about water being energy and water needing to be alive. And on the right side here we see work of Masaru Emoto, who told us about the hidden messages in water. If you freeze water after having spoken to it in a beautiful manner, or if you have said I love you to a bottle of water, or thank you, you get beautiful crystals like this. And if you were to say I hate you, you are terrible, you are miserable, and you send this vibe into a water bottle, freeze that water and you get terrible looking ice crystals. Isn't that crazy? And Vida Austin is a great woman who's now doing similar work and is getting actually messages from the water that are not just water crystals. They are actually showing words, numbers, symbols, pictures. So let's not even go there, but water is life. Water holds the key to our human survival. So we need to understand our watershed, and we are looking at pattern language. And to help us in our design, we want to make things as easy as possible. And so rhymes and numbers, they maybe can help us. Although, of course, we are totally aware that this is just something to help us as humans who are not aware of the larger picture and how it all works, to help us get into sync with water. So we're looking at a watershed, and we see that there are 4 patterns, 4 parts in any watershed. There is an area where we catch water, where water falls on the surface and flows down or in a direction of lesser pressure. Then we can also conduct waters. We have rivers that make water go from one side to another and maybe not so fast downwards. So these are conducing channels, conductions. Storage, there is lots of storages in lakes or in pits, and we can put them in our homes as well. We'll look at this later. And then, of course, we're distributing through deltas and through smaller creeks. And this is what we can find in any watershed all over the world. And now the quality of each of these parts in a watershed will make the quality of the final water that we get at the end of the watershed, or that we can enjoy in the middle. So if we have water falling on a catchment area that is full of rubbish, full of trash, all the rest will be contaminated. So we need to keep our catchment zones as clear as possible. So there's also 4 areas to work in when we want to restore the watershed. We will be working in topography. We will be looking at how can we work with what is there, what is the landform, how are some land shapes or land sides more protected or more exposed, and we will work with this as much as we can, and sometimes help along and move some soil around. We will have water bodies. We can make sure that the water body that is already existing has the toppest of the bests of the primary qualities, or we can make new water bodies, or just help water sit in the land and have it do its natural thing, like, for example, beavers used to do. They used to make a water body and help the land rehydrate without anybody else telling them what to do. Now, we need to also look at vegetation and soil. As I said earlier, water cannot regenerate our watershed on its own. We need vegetation and we need soil, and we need to look at the density, the type of vegetation. We need to maybe focus right now in our current situation and in areas that are largely desertified. We need to focus on more lignin dense shrubs and trees so that we have woody material, so that we have carbon, not just to catch the carbon from the air, but also to put it back in the soil and to cover the soil, because we have way too much nitrogen in our soils currently because of fertilizing, and we have way too little carbon in the soils where it should be. It's now all up in the air, yet it's not just carbon up in the air. Remember, there is all this water vapor as well as strong greenhouse gas that also has its effect on the heating of the seas, etc. And so what is the biggest storage of water in our landscape, in our watershed? Is it the lake? No, it's the soil. Every 1% of organic matter in the soil is capable of holding up to 200,000 liters of water per hectare. Now, if you know something about soil, in the soil basics, we see that a living soil should have approximately 4 to 5% of organic matter. Then there is a whole bunch of airspace, and we also need some water, which kind of together come up to half of the soil space, let's say, water and air. And that means there's 45% left, and they are made up of minerals. And in the organic matter, that's where we also have the structure, the microbiology that will be decomposing this, and that is actually helping us to make this glutinous structure and charge the soil with the, now I'm getting into way too scientific details, but just so you know, soil needs to have organic matter in it for it to be able to store water. Our soils, and for it to be able to then, of course, also cultivate our food and give us 95% of our human diet. Only 5% comes from the sea, and the seas are struggling for that as well. So 95% of our food comes from the soil. A healthy soil needs 5% organic matter. 1% organic matter can hold up to 200,000 liters of water, or helps the soil be able to store this water. And currently our soils have between 0.5 and 1% of organic matter. Theoretically, when you go lower than 1, the soil is dead. And we are eating this food. So that's our context today. So this is where we need to start working to restore our watershed, to restore our water cycle. We need to work to regenerate soil, work with intelligent vegetation. We need to maintain or create water bodies to keep the water on the land and infiltrating into the land around it. And sometimes we may need to work with topography as best as we can, because there is slope or there is no slope. And so we will look at all these patterns and work with nature so that the watershed and the water cycle can restore itself again, and the green small water cycle can kick into place again. And now this is for landscape design or for people with access to land, but no, we can also do something in our homes. In future recordings, I will be sharing what you can do in your home. And your home is actually also a watershed in and of itself. We have catchment areas on the roof. We have channeling and gutters that is kind of conducting the water into deposits, which you could call a water body. And from there, it's distributed into the house. And then once we use the water in our house, we actually distribute it out of our house again, maybe to a purifying plant, maybe to our garden, maybe to a black hole. So our home is also a watershed in and of itself. And we need to also look at 4 areas of intervention. Again, we're going to stick with 4 to keep it easy, to keep it easier to remind ourselves what are the areas of intervention, where can we engage in watershed restoration. When we're talking of our homes, we can catch and store rainwater rather than work with deep well water or with tap water. Living within our rainfall footprint should be a goal that we all want to be working towards. And yes, it is possible also with lower rainfall numbers. It's easier, of course, when you have lots of rain, and then people may forget, oh, we don't have a problem with the water cycle. But just quickly on this topic, the climate feedback loops and the climate chaos is actually going to be harder felt in areas that have high rainfall traditionally, because as soon as they have one dry summer, one spell of drought, the vegetation is a lot more fragile in the face of this extreme. So get ready. Be prepared for the drought because it is coming. The atmospheric rivers are out of order. So we want to be living within our rainwater footprint. We want to be reducing the use of fresh water because there's ever more people on the planet. We need to be sharing the water resource, and we need to, of course, definitely be sharing it with our ecosystem and with the vegetation and all the other living beings in it. So whatever we then use and contaminate, the problem is the solution. So please try to not contaminate. Why do you need to use bleach, which is a biocide, which may well do well for you to not come into contact with any disease on the surface of your kitchen top, which I doubt would take place if you are actually buying organic food and if you are just neat and cleaning up after yourself every time you cook a meal, etc. Really, you shouldn't be needing bleach, because what you are doing is you're not just killing the bacteria on the surface, on the worktop, you are killing everything that then comes after it. The bacteria in the drain pipes, the bacteria in the deposits, the bacteria in the purifying plants, the bacteria in the sea. And may I remind you that bacteria are actually a good thing. We exist of more than half bacteria that are not human cells. So we also depend on microbiology, bacteria, microorganisms, to actually decompose the carbon, the organic matter, to store then the water in our soils, to feed the plant with this water. This all depends on microbiology, on bacteria. So biocides, pesticides, anything chemical in your shampoo, or too much foam in your washing up liquid, or salts in your washing up machine, or massive amounts of soap in your tumbler, sorry, in your washing machine. It's just not necessary. So try to not contaminate, and specifically try to keep anything out of the water that hasn't come through your body or is off your body. So please, no Tampax, no plastics, no rubbish in the toilet or in the shower or wherever, in the river, in the sea. The problem is a solution. Let's not contaminate. And whatever we do contaminate, as in use biodegradable soaps and whatever we wash ourselves with in the shower, or whatever we wash our clothes with, if it is as biodegradable as possible, the microbiology in the plants, in the soil, in the vermifilter, in the very different types of wastewater purifying systems that exist in a biodigester, they all depend on microbiology, and they will clean your mess. So there's no such thing as waste. There is lots of science happening right now, lots of investigation going into fungi and bacteria who actually also break down plastics and heavy metals. So there is probably nothing that microbiology can do. Yet this doesn't give you a license to actually just keep contaminating the water. So stop contaminating the water or minimize the contaminating effect that we have, then regenerate the water and reuse it in your immediate surroundings. Don't send it off far away. That has a huge energetic footprint. And last but not least, this is something that you also engage in your home, although it's not a fixing, it's not something physical in your house. Your conscious purchase, your consumerism behavior will have a huge amount of effect on the whole water cycle, because 10% of the water, the fresh water available to us in the world, is used in our homes. 10% only. 70% is used in agriculture. That means what we eat, that depends how water is being used in agriculture. 20% is used in industry. What we buy, especially fashion, has a huge effect on the water cycle. And how many liters of water go into your t-shirt? Wow, you should not be buying a t-shirt every week, because it actually uses the amount of water that one person uses for drinking in 2.5 years. So the conscious purchase is another tool that we have in our tool bag and that we can leverage hugely in pro of the restoration of the water cycle, in favor of the restoration of our watershed. So up till here for now. In next recordings, we'll look closer at water in the landscape and how do you start designing your regenerative solutions, the solutions based on nature, to actually keep the water on the continent longer, to slow water, to retain water, to infiltrate water. And we will also have another recording for how to use water in the home. How do you install and measure deposits for rainwater? How do you actually reduce the use in your home? And once you have used it, which systems exist to regenerate and reuse in your own garden? This for future recordings, and thank you for taking an interest in restoring your own water cycle and doing whatever you can, because every drop counts. Thank you.